C# constructor inheritance. In C#, it uses base and this keyword to invoke the each constructor in base and derived classes. Base classes are automatically instantiated before derived classes. In this example, parent class is the base class and it have initialized two constructors. First one has no parameters and second one has a string parameter. Here the child class is the derived class and it uses the base keyword to invoke the constructor of the base class. Note the base bit, that's saying which other constructor should be invoked before any of the rest of the code in the constructor runs. Every constructor of every class other than plain object does this either explicitly or implicitly. Here, executing the derived class which has initialized a parameterless constructor in first line, and here it uses the base keyword to inherit base class constructor with a string parameter. Then it will invoke base class constructor before running the rest of the code in the derived class constructor with passing from derived string to the base class constructor, and it will print as the first output. After executing the base constructor, it will execute rest of the coding have in the derived class constructor, so as the second print statement it will display child constructor. This code segment illustrates how to use the keyword to implement the constructor inheritance in C#. Here, the first constructor of the derived class invokes the second constructor which have an integer parameter. Then it will pass the value 5 to the constructor and that value will increase by one side the constructor, then it will display value 6 as the first output. After executing the second constructor, it will run rest of the code segment inside the first constructor. How inheritance used in C++? C++ is considered to be a multi-paradigm language, of which one paradigm it supports is object orientation. Thus, C++ is not a pure object-oriented language. Key properties of C++ inheritance. The base or derived class relationship is explicitly recognized in C++ by predefined standard conversations. When combined with dynamic binding, this special relationship between inherited class types promotes a type-secure polymorphic style of programming. Visualizing inheritance. A type called a subclass or derived type can inherit the characteristics of another type called a superclass or base type. The term subclass is equivalent to derived type. Base class and derived class. Using inheritance, one can create general class that defines traits common to set of related items. This class can then be inherited by the other classes by using the properties of the existing ones with the addition of its own unique properties. The old class is referred to as the base class, and the new classes which are inherited from the base class are called derived classes. The class B contains the three-member property 1, property 2, and property 3. The second class, named as D, contains 4 members in the property 1, property 2, property 3, and property 4. The derived class D also contains the same 3 properties as those in the base class B. Instead of defining these properties again, they can be reused or inherited from the base class B. Instead of defining these properties again, they can be reused or inherited from the base class B. Out of these 3 members, property 1, property 2, property 3 of the class D are same as that of class B, while the one member in the property 4 is unique. In the class D, Instead of defining all the three members again, one can reuse them from the class B. This feature is known as inheritance, which saves time, space, money, and increases the reliability and efficiency. A derived class can be defined as follows. Create a derived class by adding a colon after the name of the derived class followed by the name of the base class. This code declares a new class, child class, that derives from parent class. You can read the colon as derives from. If no access specifier is specified, it is private by default. The access specifier indicates whether the members of the base class are privately derived or publicly derived. Adding, changing, and hiding members. We mentioned that one of the biggest benefits of using derived classes is the ability to reuse already written code. You can inherit the base class functionality and then add new functionality, modify existing functionality, or hide functionality you don't want. First, let's start with a simple base class. Now, let's create a derived class that inherits from base. Because we want derived to be able to set the value of mn value when derived objects are instantiated, we'll make the derived constructor called the base constructor in the initialization list. Adding new functionality. We have access to the source code of the base class. We could add functionality directly to base. Normally, we would rather write an access function in the base class, but for the sake of example, we are going to add it to the derived class instead. Because mn value has been declared as protected in the base class, derived has direct access to it. To add new functionality to derived class, simply declare the functionality in the derived class like normal.